Hello YouTube, De-bodgery here. Welcome to EV Components Review. On the bench is the Power TP128 internal permanent magnet inrunner motor. This is the exact same motor that Lightning Rod sells as an XXL. There is zero differences. He just charges you more for them, and he gets them exactly like this. He does add a temp sensor, and I believe that's the only thing he does to them, because they do not come from Power with a sensor in them. Anyway, I bought 3 of these things, and I paid $250, including shipping for them. So, yeah, you can get them very inexpensively. They're not super expensive to begin with, and yeah, you can get them with a couple different shaft options. So this is the 12mm shaft, and this is exactly how Lightning Rod gets them. I believe he gets them with a 12mm shaft, and then he's got a little sleeve that slides on there that adapts at the 3/4, and it's got an internal keyway that goes in here, and an external keyway to go for like number 35 or 219 sprockets. Anyway, you can get them like this, or for no extra cost, you can also get them like this. And so this is 20mm right here, and this is 0.79 inches across, 20mm is. So a 3/4 inch ID sprocket, like your typical number 35 or 219, if you heat it up, you probably can slide it right on there, and it will make a nice tight fit on here. Worst case scenario, if it's a little bit too tight, you could put this on a lathe and machine it down just ever so slightly to exactly 3/4 of an inch to make all of your 219 and number 35 sprockets slide right on. But yeah, I was getting them like this with the 12mm shaft, and the salesman for Power, he said, "Hey, we also sell them with a 20mm shaft." And I went, "Oh, really? Okay. So send me 3 of the 20mm shafts." So yeah, I got them all with the 12s, and also got 3 extra shafts. So yeah, he was super helpful, very friendly guy, very outgoing. One of the few Chinese salespeople that I definitely appreciated doing business with. Anyway, yeah, that's the 2 shaft options that you've got. The motor windings the phase wires look super beefy. And when I saw this, like, Jesus, those are incredible. But this is a gimmick, and I will show that to you in a minute. Here is your Hall cable, and there's only 5 pins in there because there's no temp sensor. So there's just plus 5 volts ground and your 3 Hall signals, and that's it. Anyway, yeah, this is exactly what Lightning Rods buys. So yeah, you're buying a Power TP128 when you buy an XXL from Lightning Rods. And here it is. Alright, let me set this on the floor and grab the armature. And here is that. Alright, so as you can see, it is IPM, and these V's in here are quite deep. I believe that what's going to happen here is that because these V's are so deep, that here in the middle, the magnetic field is probably going to be about 1/3 or less, maybe 1/4 of what it is out here and here. So these are going to be your 2 strong spots, and it's probably going to be exceedingly diminished right here in the middle just because there's so much depth of laminations right there. That's my theory. We'll find out in the next video. There are 10 magnet poles here, so 5 pole pairs. IPMs are great for RPMs. IPMs are great for RPMs. Boy, that's not a tongue twister. Yeah, you really don't get grunt out of these motors. You know, they're not really meant for low RPM use. You really want to get them going. Because you know, if you really want best case torque, low RPMs, then you really want a surface permanent magnet SPMs. You know, like the factory Surron motor and the factory, I think the Teleria motor is the same way. Yeah, the magnets are on the surface. And you know, if your motor is going slow, low RPMs, that's much better than is IPM. IPM is really intended for lots of RPMs in the motor, and then with all the iron on the surface like this, you can also use field weakening with it, which isn't really very effective with a surface permanent magnet motor like, say, the Surron. So anyway, yeah, this is you know, MTPA is useful for this. You know, field weakening is useful for it, and higher RPMs. Not really meant for a low RPM motor. But anyway, this is, let me grab my micrometer here. So here's that. I believe that was 70 millimeters across. I think that's right. And, 74, sorry. Bugger, get off there. So 74 millimeters across. I can't get my micrometer across here just because this cover is in the way, and I'll talk about that in a minute. But this is 70 millimeters long across there. So 74 millimeters by 70 millimeters and 5 pole pairs. So here is the front cover, and you'll notice that you can see the bearing. If you look inside there, yeah, you can see it. So there is a shoulder that the bearing sits on inside the shell. So this can't come off this way because it's trapped on the bearing. So I don't know why they did that, because you can't get it off because that stupid shoulder back there. Like on the HLD 50 millimeter motor, which Lightning Rod sells as a big block, it's done the other way around. So the shoulder is on this surface right here, and then that makes this whole cover be able to slide right off of the bearing. With this design, it's trapped on the bearing. You have to pull all this off some other way. And yeah, this is a bit of a pain. So this shaft, other than this 12 millimeter versus 20 millimeters, is otherwise identical. So you can see this shoulder right here, and this is the area that the bearing sits on. So here is that shoulder right there. And so the bearing is trapped behind this shoulder. So you can't get the bearing out without pressing the shaft out. Whoops, don't do that. Without pressing the shaft out of the armature. So you can't get the faceplate off. You can't get the bearing out without pressing the shaft out of the armature. What were they thinking? That's the dumbest thing ever. What they should have done is taken the shoulder and put it here instead. This is 20 millimeters. This is 20 millimeters. Put the shoulder back there. That way the whole bearing can slide off this way. And then this shoulder back here, put it out here so that this whole faceplate can come off. This is massive hassle factor to get a bearing off or to get the faceplate off, because you've got to do both the same way. You have to press the shaft out of the armature in order for you to get at the bearing or the front cover. And that's dumb. just don't do this. Yeah. Anyway, not a very great plan. No idea why they did that. But yeah, there it is. It's a Top Power TP128. Exact same motor that Lightning Rod sells as an XXL. So let's look at the stator real quick. Set this on the floor. All right. So here is one of the phase ends coming out of the motor. Yeah, there we go. See it a little bit better maybe. And then this right here, this is 10-AUG wire. So I was telling you about a gimmick. Well, here is the gimmick. This is a nylon sleeve that goes over the wires. So yeah, when you get it, you see this like you saw when I had the completed motor up on the bench. And then this Teflon wires inside there. So it looks like you're getting these massive phase wires, and you're not. You're getting 10-AUG wire. So here is a section of 10-AUG wire, and let me take the end of, oops, sorry about that. Take the end of this blue wire right here, and well, that shows up on camera, but those are the same diameter. So yeah, it's 10-AUG wire inside this ridiculous vinyl sleeve that makes it look really big. I have no idea why they did this. Is this just some marketing gimmick to make you think you've got massive phase wires when you don't? Yeah, when I took the motor apart, I could see the ends, sticking out right here, or rather right there, because, it's got this little sleeve on here, and I could see a little piece of this wire in there. Thought, what in the world is that? That's clearly Teflon wire in there. And then I looked a little bit closer, and I saw that silly plastic, vinyl sleeve was on the outside of it, and I went, okay, those are going away like ASAP. So I have slid them all off, all three of the phase wires. It's completely pointless to have them there. No idea why they did that. Just marketing hype to make you think you got bigger wires? That doesn't make any sense to me at all. Anyway, I will probably change this out. So all these strands right here, they're all equivalent to about 8 AUG, whereas this is 10 AUG wire. So, you know, if you want best case current carrying, then you want to have your phase wires, or your windings rather, to be the same size as your phase wires. And so this is going to be a current choke point, and you're going to be able to carry more current in the phase windings than you will in the actual phase wires. Yeah, that's another tongue twister, right? Phase windings versus phase wires, kind of like IPM and whatever the other thing I said. Anyway, as far as the windings are concerned, they're well secured. They've got plenty of shellac on them. There was a bunch more zip ties on here, and I've taken all that stuff up so I can pull these wires loose like this. Don't like zip ties, and especially not. I like zip ties, just don't like them in motors. So zip ties are plastic, duh, right? And so zip ties on something that gets very hot, like a motor, means that they're going to either burn or melt. You know, if the motor gets pretty hot. In the windings, they're probably going to be just fine. So zip ties are not a great solution, and then they break, and then they can possibly fall inside the motor, and they're hard. And being that they are hard, they can also potentially cut into the insulation on the wires, and none of that's very good. So yeah, I'm going to clip all these off, and I'm going to replace all that stuff with winding thread, which is going to be able to handle the 200 degrees Celsius that hopefully the insulation on the wires has. So yeah, zip ties are cheap and quick and easy, but it's not the right solution. You really should be using winding thread instead. They do have plenty of shellac on here, so all these strands are pretty nice and tight. There's not really very much movement in here, so this is definitely better than even like the QS165 V2, which was a heck of a lot better than the V1. But I would say that as far as the quality of attention to detail and getting all the strands down things, this is definitely better than that is. And, you know, who's heard of Top Power, right? But everybody's heard of QS Motor. But yeah, I would definitely say this is better. I'm probably definitely going to replace this. You know, get rid of these 10 AUG wires and replace them with 8. And I have 8 AUG Teflon wire. Here is your Y termination right there, underneath there. And this is probably about as ideal as you can get as a termination is concerned. So they have some kind of a hot tool. I've seen a YouTube video on it in use, but it basically creates a ton of heat right at the ends. You don't even have to like strip the insulation off the strands. You just put this thing over there, and it, you know, makes enough heat to be able to melt copper, and so it creates this little blob on the end like that. It's solid copper. So all those strands are welded together, copper to copper to copper, really nicely. You can't get a better joint than that. And it's super quick and it's super cheap to do. So I don't mind solutions like this. And in fact, like right here on this blue phase, you can see they did the same thing. Yeah, it's very quick, it's very efficient, and it's, well, pretty darn solid. And there's nothing you got to do to make that work. It's very, very, very simple to do. So don't have any problems with that kind of thing. Definitely don't like zip ties. Those got to go. All right, so here is your hull board right there. And by the way, there are 12 stator teeth in here. As you can see, I wrote 12T on there to remind me. You can see one of the hulls right there and there and there, and there's like a little slot in between the stator teeth for that to drop into. So as far as if you have a bad hull, it's a fairly mundane thing to replace. You just pull the back cap off, which is right here. So you just take 6 screws out, and here is one of those, and then you can pull this away. And by the way, it had silicone all around here to seal it, but yeah, take that off, and then you can clip those zip ties, pull this little hull board out, replace the bad hulls, put it all back together again, and ta-da, you're back in business. So that's a fairly mundane thing to repair. Hull boards make that very easy to do, and I don't know that they're super glued in. Yeah, I think they are. They're not moving at all. These zip ties are, as you can see, not exactly very tight, and that's another thing I like about zip ties. Yeah. Anyway, yeah, I think they're super glued into those slots, which kind of sucks. Well, it does make it so they can't pop out. Yeah, yeah, it's not moving. They can move the board, and the hull is not coming out. Anyway, so there's your hull board. Expect another video here pretty quick when I pull out my milliometer and LCR meter and Gauss meter and all that kind of stuff. But anyway, I think that's probably everything I want to show for here. It's got an extruded aluminum outer shell. It's probably going to cool pretty decently with just that. Yeah, that's pretty much everything here. Hope that helps some folks out. And expect another video on the TP128 from Top Power to come pretty soon.